A very good morning, doctor. My name is NARVINRAJ, son of PERMALU. My matrix number is 241361690. Okay. Today I would like to present my solution and evaluation for exercise 4.1a and 4.2a and 4.3a from lab 4 Laplace transform. Okay. Here you can see my 4.1a coding. Okay. First I want to show the command window. So here you can see my command window. I already attached these commands in my answer sheets. Okay, now I would like to explain this coding. Okay. First, this A equals to 2536, and then B equals to 16116, and X equals to TFAB. Okay, here I define the numerator and denominator uh, of the transfer function as vectors. Okay, and then this RPK equals to residue AB. Okay, this RPK means the R equals to residues, and then the P equals to poles, then the K equals to direct polynomial terms. And this decomposition is useful for applying the inverse Laplace transform. After that, the SYS equals to ZPKX. Okay, this means this gives the zero poles gain form, now showing the locations of zeros and poles of the system. Okay, after that, the SYMS, ST, and then the following lines, Fs equals to 2s3, 5s2 plus 3s plus 6, that's 3 plus s2 plus 11s plus 6, and then Ft equals to I Laplace Fs, PTFT, and then this means the symbolic code computes the inverse Laplace transform of the transfer function. The results, the Ft is the time domain output of the system. Okay. Next, I want to explain the 4.2a coding. As usual, I want to show the command window first. Here's the command window. Here's the commands for the 4.2a. This task required to finding poles and zeros. Then showing the magnitude response, that means the graph. So you can see the graphs also. This is the magnitude graph. Then this is the praise degrees. Okay, now I want to explain about this coding. Okay, this A equals to 1001, then B equals to 10201, then X equals to TFAB. This define the transfer function. After that, the RPK equals to residue AB as usual. Again, this give the partial fraction expansion of the function. And then the SYS equals to ZPKX. This displays the zeros and poles clearly. And then here we can see the Z-plane AB. Here this Z-plane AB, this command plots as the zeros and poles on the complex, and the S-plane. Zeros are shown as circles and poles as crosses, as we studied in our theory classes, The last one is Fricks AB. This plots the frequency response of the system. It shows how the system behave at the different frequencies. So lastly, I would like to explain this coding. At first, showing the command window first. Here's the command window for the 4.3a. That's the symbolic inverse Laplace. In this exercise, we use symbolic computation to find the time domain function from a Laplace domain equation. Okay. This is a simple coding. Okay, here I define the Laplace function, that is fs equals to s plus 3, and then s cube plus 7s square plus 10s. Then use the I Laplace to compute the inverse Laplace transform. Then the MATLAB returned the exact symbolic expression in term of t, which represent the system response of the time domain. So that's it for today. Thank you so much.